All right, so now we're going to go through the geological and biological history of the Earth. Some of this we've already done when we talked about the formation of the solar system and the formation of the Earth. So some of this I'm just going to skip over, and other parts of it I need to talk about in a little bit more detail. So that the Earth begins about 4.55 billion years ago. And so we're going to have a cosmic calendar, and we're going to take this 4.55 billion years and compress it into one calendar year. So the Earth would have been born on January the 1st of this calendar year. And so the Earth is going to be molten from the impacts of all the debris that made the Earth. So you should already know that. Okay, then the next thing that's going to happen is about 4.4 billion years ago, the Earth is going to be hit by an object about the size of Mars, and then the debris from that is going to be blown into orbit, and then that's going to form the moon. You should already know that. But what's interesting is that the Earth may have had an atmosphere, and the Earth may have had an ocean prior to this impact. And if the Earth had an ocean, it had liquid water, there might have been some bacteria in that ocean. But we'll never know, because this impact completely vaporized the oceans, and it vaporized the atmosphere, and it completely destroyed the surface of the Earth, so that we just don't know if there ever was anything prior to this impact. Okay, then the next thing that's going to happen is that volcanoes are going to be erupting, and volcanoes give off water, and they give off carbon dioxide. So the carbon dioxide and methane are going to make up the first atmosphere of the Earth, and then the water is eventually going to condense and is going to fall as rain, and is going to make the first oceans. Another way that the Earth could have gotten carbon dioxide and water is from the impacts of comets, because comets contain mostly water, ice, and carbon dioxide ice. Another thing is just the impacts of all the asteroids. An asteroid contains about 1% water. So that means that if you're being hit by millions and millions of tons of asteroids, that's a lot of water that would be released. So the Earth now has a very primitive atmosphere, and it also has liquid water oceans. All right, now this is new though. So the first life comes on the scene, we think, about 3.7 billion years ago. So this would be March the 20th on our cosmic calendar. And this first life is going to be chemosynthetic bacteria. So that means it's going to take the chemicals that come out of underwater volcanoes and is going to use that as their food source. So it's a kind of bacteria, and it would have used the materials that would have come from underwater volcanoes as its food source. So this slide here, again, I just want to show you that there are all sorts of different kinds of bacteria, and there is three basic kinds of life. So you have bacterial life, archaeal life, and then also eukaryotic life. And so the earliest kind of life would have been this archaeal type of life. It has characteristics of being both bacteria and eukaryotic life. Eukaryotic life means it's multiple cells that are put together. The bacterial and the archaeal are single-celled organisms. So you don't need to know any of this chemistry, but I just want you to see that these primitive kinds of life eat basically anything, and they can use that as their energy source. So we're used to photosynthetic bacteria that can take, for example, water and carbon dioxide, and it can take light and then use that to manufacture its organic parts. But there are other kinds of life, bacterial life, that likes to eat methane. Things that would be poisonous to us, this kind of bacteria can digest. Now this is very important. So 3.4 billion years ago, a new kind of life takes hold on Earth. So this one is photosynthetic bacteria. So this kind of bacteria is going to take carbon dioxide and water and sunlight and use that as its energy source to make organic materials. And so these are pictures of algal stromatolites. And so what happens is that you have a mat of these bacteria that live at the surface, and so they're taking carbon dioxide and water and using that to live on. But they're very close to the shoreline, so what's going to happen is silt and stuff is going to cover them up and is going to kill them. But as soon as that happens, more bacteria start to grow on top of the dead bacteria. And then more sediment comes in and covers them up, and then more bacteria begin to grow on top of that. So that what you're going to get is a mound-like structure that is going to stick up out of the water. And so these are called algal stromatolites. Now this is huge because a waste product of this process is oxygen. So in the same way that when our waste product is carbon dioxide, when we breathe out carbon dioxide. The waste product of these bacteria is oxygen. And this made the first mass extinction in the history of the Earth, because a lot of bacteria don't like oxygen. And so as this oxygen starts to go into the air, it almost immediately starts to go back into the ocean. And so that oxygen in the water began to kill the kind of bacteria that don't like oxygen. So this was like the first mass extinction in the history of the Earth. And so what this oxygen did was it reacted with the iron that was dissolved in the ocean water, and it made rust. And then this rust began to accumulate on the bottom of the ocean floor. And layer after layer of it developed, and today we mine it. So up in Michigan, in North America, in the state of Michigan, they actually mine these layers of rust, and then they get the iron out of it, and then that's where steel comes from. So basically all the steel, at least here in North America, comes from these red beds that are in the state of Michigan. All right, let's keep going here. So Earth has had many supercontinents. So the last time that all the continents were put together was called Pangea. But the supercontinent that came before Pangea was called Rodinia. And Rodinia has the distinction that when all of these continents came together, they blocked the ocean circulation. So that if this is a picture of the Earth, this down here is the southern hemisphere, this is the northern hemisphere, and then Rodinia was a supercontinent that covered pretty much all of the southern part of the Earth, and then part of the supercontinent came up here, and part of it came up here, and then that blocked the global ocean circulation. And when that happened, that triggered an ice age. And so this ice age was so bad that we think that the entire Earth was frozen completely solid to a depth of 1 mile. So 1 mile deep, the entire surface of the Earth was covered in ice. And the global temperature went down to negative 40 degrees Fahrenheit. So it got very cold. Now you might think that that would have killed off all of life, but remember, the kind of life that would have been living at this time would have been bacteria. And we know that bacteria is very, very hardy materials. So it was able to survive. And then the reason why what happened that got rid of all the ice is that Rodinia began to break apart into separate continents. And we know that when a continent breaks apart, volcanoes erupt, and so you end up with the mid-ocean ridge when that happens at a diverging plate. And so these volcanoes erupting gave off a lot of heat. That helped to melt the ice. Volcanoes also give off carbon dioxide, and that carbon dioxide causes greenhouse gases, which help to warm the climate, and eventually it melted away all of this ice. So now we're up to about 700 million years ago. And so on our cosmic calendar, we're now on November the 8th. All right, let's take a break, and when we come back, we're going to start to look at how the continents moved around and how did life develop from that.